Killer Innovations Podcast for Sunday, August 7th, 2005, show number 22, brought to you from Washington, D.C. Welcome to the Killer Innovations Podcast. I'm your host, Phil McKinney. Before we get started, please keep in mind that the information expressed in this podcast is mine and mine alone and does not necessarily reflect the opinions of my past, current, or future employers. Well, I'm back from New York City and just getting ready to head out to San Francisco and Los Angeles. I'm actually trying to get this podcast out here late Saturday night, but most likely it'll get posted early Sunday morning. But with the travel schedule coming up, it looks like my time here at the house in Washington, D.C. is coming to an end. As the travel schedule wraps up, I'll be heading to Europe and into Hong Kong, Asia Pacific here in end of August going into September. I did receive a few submissions of last week's homework assignment. I'm still looking for more. As a reminder, the assignment is for you to send an email describing how you've applied one or more of the items discussed in the podcast. I'll collect them up and share them on an upcoming podcast where we all can learn, including me, about how you are applying the ideas, tools, tricks in this podcast, either from myself or from the books and references that I've shared. Thanks for all the comments that have come in. If you have suggestions, feedback, or just words of encouragement, please send them my way. And please join in on the conversation at the Killer Innovations community site. There's lots of looking. It's a community board that people can all participate in. A lot of people are looking, but now it's time to join in. This podcast is not a passive experience. Looking for people to actually join into the dialogue. So click on the KI community button on the killerinnovations.com site. Now you can reach me at podcast@killerinnovations.com, or you can leave me a voicemail message on the feedback line, 703-636-4460, or you can reach me on Skype at Phil_McKinney. In today's show, we're going to take a change in the format to accommodate a topic that I've uncovered through my readings that I think deserves it. A few months back probably early, I guess it was late spring, I purchased Bruce Mau and Jennifer Leonard's latest book called Massive Change. Now, if you don't know who Bruce Mau is, he's one of the big top designers. He's based in Toronto. Just a phenomenally creative individual. He's had a number of books published, runs a phenomenal design studio, and this was his big book that was coming out this year on Massive Change. Now, the book is about the role of design, or more specifically, Bruce and Jennifer have turned the topic on its head and have said really the purpose of the book is about the design of the world. Now, one topic in the book caught my attention, which was an interview with Janine Benyus around the topic of biomimicry. Now, biomimicry is the use of biology to mimic or look at mimicking biology as a source of ideas and insights for innovations. And Janine is the author of the book Biomimicry: Innovations Inspired by Nature. Now, as part of the background and research that went into creating the book Massive Change, Jennifer Leonard hosted a radio program at the University of Toronto on CIUT 89.5. The name of the program was called Massive Change Radio, and it was really these interviews that Jennifer did that found their way into the book and became kind of the seed that was used to pull this material or pull together this thought leadership around this whole area of design of the world. Now, the format of the program is to have one or more thought leaders come in on the program and share their thoughts, and Jennifer would interview them. Now, I tracked down the interview with Janine, and Jennifer has graciously given Killer Innovations permission to replay segments for our listeners. So, I've gone through the entire 1 hour show and have selected out segments that I found interesting and ones that really highlighted the whole concept behind biomimicry. So therefore, I'm taking some indulgences to the normal format to share with you what I hope you find as interesting as I did. Now, one word of caution. You're going to notice that the audio quality during the interview segments is a little rough. Now, bear with it. The content is well worth it. When I was reading Massive Change and came across the term biomimicry, I had no idea what it was about. You could pretty much guess from the word that it has something to do with biology and mimicry, something to do with mimicking. And then listening to the radio interview and reading the book, it hit upon me really as being an example of really looking at alternative industries for ideas and methods. In this case, it's really not an industry. It's how do you look at biology and all the things that animals have adapted over millions of years in order to be able to survive. And how do you apply that potentially to give you ideas for innovations? And I thought this was really a good example, and it marries up very much so with the topics that we discovered on the May 30th podcast, which was really looking at kind of random industries and looking, if you're in telecom, look at financial services. If you're in manufacturing, look at the government for ideas about how they do things. In this case, it's not so much industry, it's looking at the sciences. The real question is what would prompt anyone to even look into this space?
My question was, is anybody out there trying to look here for sustainable solutions? I mean, here they are. And what surprised me was how many people indeed were looking to nature and had made that the way that they innovate and research. And then the book was just a kind of a pointing to all the work in nature-based innovation that was happening.
One area that biomimicry is having a huge influence is in the area of material science. Now, Mehmet Sarkar, a leading material science researcher at the University of Washington, credits biomimetics as potentially creating a revolution that will rival the influence that the Industrial Revolution had on society. Now, this is a pretty bold claim, but I think when you look at really some of the top research in photosynthesis in Arizona, what Mehmet's doing, it is incredibly exciting about really this research at looking at biology for sources of ideas. Now, as in his own right, Mehmet is one of those researchers that is leading the change.
Mehmet is known for is this idea of looking to seashells, and he actually looks at a giant snail called the abalone. And the abalone is the one that on the inside, it has this incredible mother of pearl. And so, and this mother of pearl, in addition to being incredibly beautiful and iridescent, is like twice as tough as our high-tech ceramics. The ceramics we put in a jet engine are not as tough as what's on the inside of this shell. And so he began to look at, what was it that made it so tough? And he found that it was this layered structure that was mineral, a layer of mineral separated by a layer of very soft, squishy material. And just in looking at this sort of puff pastry sort of layering effect has changed the way materials are being made. And then he went further and said, he and many researchers who are looking at abalone said, well, how is that material being made? Because that's the real paradigm change. I mean, changing the architecture of how we lay up our materials is one thing. But the fact that we still, when we make ceramics, we still heat a kiln up to enormous, 1,200, 1,400 degrees Fahrenheit for 12 hours, 14 hours. And, of course, the abalone shell doesn't do that. It doesn't work with heat or high pressures or chemicals. It doesn't do this heat, beat, and treat. So he said, could we make materials, really materials, at room temperature, at seawater temperature? And the real breakthroughs are coming in this idea of what's called self-assembling materials, in which, just in the same way as the abalone works, the abalone puts out a template of organic material which has charges on it, a sheet. Think of a sheet of proteins with positive and negative charges. And the seawater has all these ions with positive and negative charges, calcium and carbonate. And these start to mineralize. They land on these landing sites, mineralize into a crystal. They actually self-assemble silently, and that's now being mimicked. Since the book's come out, I talk about this when I'm giving presentations. I talk about Jeff Brinker, who's in Albuquerque, Sandia National Labs, and he's found a coating technology based on the abalone that basically you dip something into a vat of water and minerals and this organic material that acts as the squishy stuff, and those layers that I talked about, they self-assemble on the surface of whatever you're trying to coat. As a liquid evaporates away, as you pull it out of the solution, liquid evaporates away and the layers form. And that, I think, is going to be the way we make products in the future. And that's coming. I mean, there's probably 10 conferences right now on self-assembling materials going on around the world.
Now, beyond seashells, there are an unending supply of ideas that can be found in nature that potentially will lead to that next killer innovation. In this next segment, Jennifer leads Janine through a series of word associations that reveal some possible weak signals for new ideas.
Hummingbirds.
Hummingbirds? Oh, my goodness. Poster child for sustainability.
Because?
Because they, in the process of getting the fuel they need, they manage to pollinate the flower. You know, they're getting nectar. They pollinate the flower, which ensures that there will be fuel next year for them or for other hummingbirds, and that is the kind of system that I would like us to have at our gas stations.
Okay. What about howler monkeys?
Howler monkeys are tremendous teachers in terms of what we should be eating. They are these masters of smart eating, as many primates are. Howler monkeys will they choose particular plants in the jungle that heal them. Basically, they self-medicate. They're able to go and choose certain plants in particular bushes and prepare them in particular ways and heal themselves. And not only heal themselves, but howler monkeys have been found to pick plants that will bring on fertility during the reproductive stage or delay it. So they seem to have not just self-medication going on, but sort of birth control.
Wow. Purple bacteria.
Purple bacteria are great. They're the ones that you see if you fly into San Francisco and you look down at the bay. Sometimes it has this purplish haze, and that's just zillions of purple bacteria. Very, very ancient kind of bacteria, and they're being studied because they actually photosynthesize. And they're also they have a pump within them that actually is able to, it's lit by the sun, and it moves ions through it in a way that none of our hydraulic engineers would be jealous, because it uses sunlight and it pumps ions through its membrane kind of upstream against gradient, just with the light of the sun.
I'm going to say wow after each one. Okay, rhinoceros horn.
Oh, rhinoceros horns. These are, a rhinoceros needs its horn for, well, besides the fact that it makes it look cool. And perhaps to females, that's an important thing. The females are sizing up that horn. But they dig with them, and when they get into fights, they use them as sort of like, swords that they parry with. And if they get a crack in that horn, it's a problem. And so what we found is that they don't seem to get cracks in the horn. And if they do, they seem to heal up. And the horn is actually made of hair. A horn, antlers are bone, horns are hair. So it's lots and lots of fibers of hair. And we find that when there's a crack, what seems to happen is that the material around the crack sort of disassembles and reassembles. It kind of pours into the crack and then reassembles. We have no idea how this happens because there are no living cells in the horn. It's dead hair. And we're looking at it as a model for self-healing structure. Say if you had a bridge that you could build it in a very lightweight way using very little material, because you knew that if it cracked at all, it would heal itself. So that's what we're trying to figure out.
And I have in my research, materials research, come across the work of Scott White at the University of Illinois. I believe he was working on self-healing plastics.
Mm-hmm.
Yeah, it's pretty fascinating, and refers to the rhinoceros horn.
Yeah. Yeah, there's self-healing plastics, and now there's some self-healing concrete, and where we put little capsules of an epoxy, of a glue-like material that when the concrete flexes, it'll break these capsules and they'll pour into the crack. Sort of our crude approximation of this amazing thing that's going on in rhino horn.
And what about coral reefs?
Coral reefs. Well, besides the fact that they're bleaching worldwide, which is one of the big problems, they're a tremendous model of what's called a type 3 ecosystem. There are a type 1 ecosystem is an ecosystem that's like a weed field that goes onto an open plain where the soil's been dug up and then weeds carpet it. That's a type 1 system. And it's a temporary system. And then berry bushes move in, and then eventually a forest. A forest would be a type 3 system. And a coral reef is like that. It's a very complex community. It's an incredible society of organisms that are in deep symbiosis with one another, symbiosis is mutually beneficial relationships. So a coral reef and a prairie and a forest, these type 3 systems, are being looked at by business managers, believe it or not, as a model for a new way to organize our whole economy, so that it's much more interconnected, interdependent, and less of the competitive model that has a lot of inherent waste in it, more of the closed loop, very tightly woven food web of something like a coral reef, where nothing is wasted. There's always somebody there to catch that next little particle of food and use it.
So what does this mean for me? How do I apply this to what I'm trying to do today? In my day-to-day job, I'm tasked with coming up with new technologies, new ideas, new products. How do I apply this to what I'm trying to do today? Now, one example that Janine gives in the role of biomimicry is with Interface Carpets. Ray Anderson, the CEO, was an early believer of Janine's work and created a group of advisors, all with backgrounds in different areas of biology, to help Interface make the change. And Janine's recommendation to Ray was,
why don't you just try giving your designers or your researchers, why don't you put them through a biomimicry course and teach them how to go outside and look to nature for inspiration. And so his main designer named David Oakey went out and took a biomimicry class. And his whole team now works in this way. The one thing they came up with, and it was really sort of only a surface look at biomimicry in the sense that it was just mimicking form. Went outside and picked up a leaf off the forest floor, looked back down at the forest floor and realized nothing had changed. It still looked incredibly beautiful. Now, what he realized was that there was this randomness going on in the natural world. Then he went back and looked at their carpets. They'd put in these carpet squares, these module carpets. And all of their carpets were perfect and had perfect patterns that you had to line up. And this was a problem because the whole sustainable story behind carpet tiles is that when one carpet tile wears out, you can pick it up, send it back to the company, and they can recycle it, and then send you a new carpet tile. You put that down, and you don't have to tear up the whole carpet. But the problem was that because we were so addicted to this perfection, you could tell that the carpet tile was new, and people didn't like that. So David Oakey said, why don't we make every carpet tile different? Why don't we introduce the randomness of the natural world into carpet tiles? And then when you lay them down, it doesn't matter what direction you lay them down in, and when you put brand new ones down, nobody will notice. And he called it entropy. And you can take the edges of the carpet roll and things you used to throw away because they didn't match, you can now use as carpet tiles. And anyway, this is their fastest selling carpet. I mean, it went to number one faster than any of their products, and now it's their best-selling product in this huge company. And we're not all sure of why that is. It's got a great story about biomimicry, but I think it's just because it makes so much sense.
With the success from this first foray into using biomimicry, Interface Carpets went on the hunt for that next idea.
The next workshop we did with them, he said, okay, they wanted to get into the hospital market. And hospitals can't use carpet tiles because they have seams, because blood and body fluids go in these seams. So they had to find a way to make the seams waterproof. So waterproofing, what in nature waterproof? So we started thinking about feathers and how when feathers hook together on a bird, you know how they zip their feathers together when they're grooming? Mm-hmm. That's to help waterproof. And we thought, wow, well, the other thing that they wanted was they wanted to use less adhesive. Because when you put carpet tiles down, you got to use adhesive around all the edges of each of the carpet tiles. So you've got a lot of adhesive on the floor. So what we came up with was a solution based on feathers that solved both problems. Because if you make the edges of the carpet tile have hooks and barbules so that you can hook them together like a feather, you can zip the carpet together as you install it, then you suddenly have a carpet where all the tiles are hooked together and it's like a big heavy sheet, like a broadloom carpet. And you suddenly have gravity holding the carpet down instead of glue.
To help facilitate the discovery of these kinds of insights, Janine is working on an open source tool that would link together biology and design concepts such as looking to waterproof, linking that to potentially feathers or skin or whatever the case might be. But linking together biology and design concepts that could be used by designers and innovators as a source of ideas. So what is the role of biomimicry in innovation? As we talked in previous podcasts, the benefit of diversity in the idea phase can be that catalyst that creates that next killer innovation. The question that we all should be asking is
there some way I can use biomimicry now to inspire my engineers to break through in some way? And so now we're in this phase of sort of being biologists at the design table. And when the question comes up, how does nature fasten? The biologist at the design table just talks about feathers and gives them a feather and a hand lens and says, how might this change what you do?
I will post in the show notes links to Massive Change Radio and Jennifer Leonard's site. Therefore, you can listen to Janine's entire interview, but you can also look at the other interviews that Jennifer did with regards to the work for Massive Change, the book, and Jennifer's also been doing ongoing interviews. And I think you'll find that very exciting and some great insight. There's some real thought leaders that are in that interview pool. It'd be a great source, and I would encourage you to find the time to listen to that. And I actually may pull other excerpts out of that out of the interview pool that Jennifer's doing, because there's just some great interviews, and the work that she's done there is just phenomenal. So let me know what you thought of this show in particular, and whether or not you think it should be something that we do maybe once a month or once every once in a while when we come across something that's very appropriate. So I know this is a little bit of a different format, but I felt letting you hear from others rather than you listening to my voice every week would be helpful in understanding alternative tools to innovation. And with that, thanks for listening. Please keep the feedback coming. Drop me an email, podcast@killerinnovations.com, or better yet, leave me a voicemail on the voicemail line, 703-636-4460, or always Skype me, Phil_McKinney. Now, we're at the start of a new month, so all of your votes for this podcast for July have been wiped out, and we need your vote on Podcast Alley. The votes and comments on Podcast Alley are the easiest way for you to say thanks for the time and effort that goes into research and producing all of your favorite podcasts. So go out to Podcast Alley and vote for the podcast that you listen to. It's great encouragement to the producers, given the time and effort that goes into pulling these things together. Please join in on the conversation about creativity, innovation, ideas, weak signals. Share your expertise or just ask questions. Ask for help. There's a bunch of listeners who are in this space, who do this day in and day out. We're all looking for ideas, but we're also looking to share. So it's just not me. There are a number of listeners who work for a number of the leading creativity firms, design firms, and they'd be more than willing to answer your questions and participate. But you have to participate in that conversation. So click on the KI Community button on killerinnovations.com and start in participating. The Killer Innovations podcast is a proud member of Tech Podcast Network. If it's tech, it's here. Visit techpodcast.com to discover the best in technology podcasts. Stay subscribed. Get others to subscribe to the killerinnovations.com podcast. And thanks for listening. We'll see you next week. Bye-bye.